Hello, welcome to A1 Tutor Live class. We're going to be having physics now. My name is Mr. George, and I'll be your physics tutor. Once again, welcome to A1 Tutor Live class. Okay, today happens to be our first class for physics, and we want to be considering a topic fundamental quantity fundamental quantity. Fundamental quantities is what we want to consider today for our physics class. So if you are pleased, if you can hear me, and as well you can see what I'm writing on the board, please kindly give a thumbs up in the chat box. You can hear me, type yes, and also you can see what I'm writing on the board, type yes, or send an emoji, so I can be rest assured that you are following me. You can hear me, type yes in the chat box, and you can see what I have on the board. If you can hear me, please signify in the chat box. And also you can see what I have on the whiteboard. Please kindly signify. I'm waiting for your response. If you can hear me, type yes in the chat box. Yes, I can hear you, or just type ordinary yes. And if you can see what I have on the whiteboard, type yes or send an emoji. I'm waiting so we can kickstart properly. I'm waiting for our responses. If you can hear me, please type yes in the chat box, and you can see what I have on the whiteboard. Type yes. You can hear me, type yes or thumbs up in the chat box. So I'll be sure that we are all on the same page. Waiting. Okay, yes, good. So we can start. We said we'll be treating fundamental quantities today as a topic in physics. And these fundamental quantities we are treating today stands as the bedrock of physics. Stands as the bedrock of physics. Is the foundational knowledge in physics. Now, let's take an illustration. We all know that we have a age. Of course, every individual have a age, whether you are 10 years, 15 years, or 13 years or so. Now, let's assume I ask one of us that what is your age? And you tell me my age is 10 years. 10 years. In some cases, we can have some very little children that their age can be just 6 months or so. Now, what I want us to understand is that age is being measured in time. And if you check the way we reply to when you are being asked, what is your age? You don't just say 10, but you said, I'm 10 years old, I'm just 6 months, I am this, I am that. What you notice is that you are always adding a unit at the back of your age. Yes, in this illustration is the unit of your age. So your age cannot just be 10, but 10 years. So the unit added to your age is years. And this brings us to the topic of fundamental quantity. In physics, we do not work without units because the foundation of physics is that there must always be an involvement of units in any calculation or experiment we are doing. And that is as a result of the definition of physics, that is the study of matter, the study of matter. And we all know that matter has weight and it occupies space. So every matter, whether liquid or solid or gaseous, has a unit. They all have a unit. And that is why we have to be very attentive with this topic, fundamental quantities. Most of the time, students do exams, they get the final answer, but they always forget to use the units. And in physics, it is considered that when you perform a calculation and your final answer does not have a unit, it's as if you've not done anything. So take note that fundamental quantity is a topic that is very important in physics. So I believe you understand that our age also has a unit, and the unit is years. And for little children that are not up to a year, it can be months. Are we getting that? So we are going to start the topic with the definition of what a quantity is. What a quantity is. A quantity. We want to define what a quantity is. A quantity. Okay. So if you check my screen now, we have something on the screen. A quantity. So we have the definition of a quantity. I said a quantity is the property of a body or a substances. A quantity. This is the property of a body or a substance that can be measured. The property of a body or a substance that can be measured is said to be quantity. And we said examples are length. We have length. Length can be measured, area, volume, or speed. So all these are examples of quantity. Now let's take, for example, we have, okay, let's say we have this representing a classroom. Of course, this is also a quantity because we can measure the dimension of the classroom. We can measure the dimension of the classroom. The schools you attend, if you check the classroom, it has a shape and it is measurable. It is measurable. We can measure the area of the class, and that also stands as a quantity. Even in the house, we have different objects in the house that can also be measured. So those objects are what? Quantity. Those objects are quantity. So we have examples of quantity to be length, area, volume, speed. We have many of them, but we just mentioned just few. Length, area, volume. We also have mass can be measured. We have mass can be measured also. Mass can be measured. So you as a person also, you're a quantity. We can measure your height. Our height can be measured. Our weight can be measured in terms of kilogram. So we also we serve as what? A quantity. We serve as what? A quantity. So a quantity is a property of a body or a substance that can be measured. That can be measured. I believe we get that. If you are with me, please let me know that you are with me by sending an emoji in the chat box. If you're on the same page, please kindly send an emoji in the chat box. We are discussing the topic fundamental quantity, and now we've defined what a quantity is. We said a quantity is a property of a body or a substance that can be measured. So if you are with me and you get that, just type yes, okay. If you are with me and you understand what I've just explained about a quantity, please thumbs up or type yes in the chat box so we can proceed. I'm waiting for a response. I'm waiting. Do you understand what a quantity is as I explained earlier? Please thumbs up or type yes so we can proceed. If you are with me, please thumbs up, thumbs up. I'm waiting for a response so we can proceed to the next. Okay, all right. So I will send a chat. I will send a picture to the chat here. And I want everyone to take a good look at it. Okay, so if you have that picture in your chat, please let me know. I sent a picture in our chat. So if you can view that picture from your own hands, please kindly let me know. A picture was sent to the chat. So if you can view the picture from your own hands, please signify that yes, I can see the picture. All right. Okay. Okay. You can check the chart. I sent a document. So there we have the picture I sent earlier. So we want to look at the different, okay, good. So if you have access to that, we'll be working with that today. We want to look at the different units of measurement. We've mentioned length. We have length as a unit of measurement. We have length. We have length. We have weight as a unit of measurement. In the chart, we also have capacity. We have capacity. We have time as a unit of measurement. So in physics, we'll be working mostly with this unit of measurement. We have the length, the weight, capacity, and time. We have length, weight, capacity, and time. So these are the units we'll be working with in this class today. We'll be working with these units specifically. So if you have the document sent earlier, you can just download it. Then you will see all I'm saying inside that chart. It is directly inside the chart that I've sent to you. So we are going to consider each of these as we proceed in this topic. We want to know what are derived quantity and what are fundamental quantity. What are derived quantity and what are fundamental quantity? What are derived quantity and what are fundamental quantity? So we're going to consider that together. I believe I can rub off the board. Can I clean the board so we can proceed with the next definition? Okay, so we want to know what are derived quantity and fundamental quantity. All right, trying to get it here. Or we look at the definition of units. Also, we'll be looking at the definition of fundamental quantity. All right, so we have this, the definition of units. We have the definition of units. We said the unit is the yardstick with which a quantity is being measured. You know, we are talking of a unit of measurement the other time, and we said we have length, and length can be measured in meter. When it comes to physics, we have weight, which is also known as mass, and that can be measured in kilogram. So those are the units of those quantities. But we have the definition of a unit to be the yardstick. The yardstick, that is the criteria that is used to measure a particular quantity. The yardstick, the criteria which is used in measuring a particular quantity, is said to be a unit. And I said earlier that in physics, every quantity has a unit. Every quantity has a unit. You can't just solve a question in physics and will not add, and probably you do not add the units to it. It is expected that every quantity, whether derived or fundamental quantity, will have a unit. Every quantity will have a unit. So we have units as the yardstick with which quantity is being measured. So the yardstick is known as the unit. Now let's look at what a fundamental quantity is as we are considering today. We said a fundamental quantity, these are basic quantities. These are basic quantities. Please take note, for the sake of exams, fundamental quantity is also known as basic quantity. In some cases, some questions will come in this form that list 5 basic quantities you know, or questions in objective in this form that which of the following is a basic quantity. So what they are referring to in that question is that what is a fundamental quantity, or which of the following is a fundamental quantity. So it's either we call it fundamental quantity or we call it a basic quantity. Fundamental quantity or basic quantity. So these are basic quantity. They are basic quantity that are independent of others units, but other units depend on them. That is, fundamental quantities can stand on their own. They do not depend on other units. Fundamental quantities can stand on their own. Fundamental quantities can stand on their own. Quantities like length. Length is a fundamental quantity. Mass is a fundamental quantity. Time is a fundamental quantity. Current is also a fundamental quantity. So quantities that can stand on their own without depending on other units are said to be fundamental quantity or basic quantity. So also we have the fundamental units. The definition is almost like that of quantity. Fundamental units are also known as basic units. Fundamental units are also known as basic units. Take note. Fundamental units are also known as basic units, and they do not depend on other units. So that means they are also independent. Fundamental units are also independent units. They can stand on their own, but other units can depend on them. So that is, they are units that can stand on their own. They do not need to depend on any other unit. I believe we get that. We've just defined what fundamental quantity is and what fundamental units are. For this example here, the unit of length is meter, and m, which represents meter, is a fundamental unit. Length is a fundamental quantity, then m is a fundamental unit. Length is a fundamental quantity and the unit is m. And that unit also is called a fundamental unit. We have mass as a quantity, fundamental quantity, and kilogram is also a fundamental unit. Kilogram is also a fundamental unit. Time is a fundamental quantity, and seconds is also a fundamental unit. A fundamental unit. Current is a fundamental quantity, that is, it's independent, and the unit is ampere. Amps is also a fundamental unit. Is also a fundamental unit. I believe we get what fundamental units are and what fundamental quantities are. I believe we get that. If you are with me, please drop an emoji in the chat box, an emoji that you are following me. drop an emoji in the chat box so I know that we are in the same page. I'm waiting for that. I'm following you. Yes. Drop a thumbs up or your own favorite emoji to show that you are following me as I'm explaining these terminologies. Okay, thank you. So let's proceed. We have defined what quantity is, what unit is, and what fundamental quantities are, what fundamental units are. So now we want to consider the example, we want to cite the examples of those fundamental quantities and their units. We want to cite that. I believe I can rub off the board now since we're on the same page. All right. So let's consider the fundamental units and their symbols, or let me say the fundamental quantities and their units. Let's consider that. All right. We have seven. We have seven basic fundamental quantities. Seven basic fundamental quantities. We have seven basic units, or let me say fundamental. Seven basic fundamental units. Fundamental. Okay, so we start with the first one we have is length. And length is measured in meter, represented by this symbol M. We have length, or we have also mass. These are the fundamental quantities measured in kilogram, and that is kg. We also have current, measured in amps, and that is represented as A. Time, measured in seconds, and that is small letter x. We also have temperature. Temperature is measured in Kelvin, and that is K. We have another one also, pressure, Pascal. We have pressure. Coming. We have, sorry, pressure is a derived quantity, not fundamental quantity. We have temperature. After that, we've taken currents. We have amount of substances, which is measured in mole. Amount of substances measured in mole. Amount of substances, and that is measured in mole, which is MOL. We also have luminous intensity, measured in candela. Luminous intensity, candela, and that is measured, and the acronyms is C and D, CD. So all I've mentioned here are the fundamental quantities and their units. We have length, measured in meter, mass, kilogram, current in amps, time in seconds, temperature in Kelvin, amount of substances in moles, and luminous intensity in candela. So all these are basic units, or we call them fundamental units, and also with their fundamental quantity. So what we have here is quantity, and this is the units. So length, mass, current, time, temperature, amount of substances, luminous intensity are all quantities, and meter, kilogram, amps, seconds, Kelvin, mole, and candela are all units. So these are the fundamental units and fundamental quantities we have in physics. I believe we get that. So we want to consider the derived quantity, the derived quantity. So can I rub off the board? So we take the definition of the derived quantities and also the definition of derived units. If yes, can I rub off the board? If yes, please type yes so that we can proceed. Can I rub off the board? Yes. I'm waiting for your response. Okay, yes. Okay, Ajaya has responded. He said yes. So let's consider the derived quantity. The derived quantity. Derived quantities. Now, we said the fundamental are independent quantities. So definitely, the derived quantity will be the opposite of fundamental quantity. So derived quantity, these are quantities, that depend on other quantities, and mostly they depend on the fundamental quantities. Derived quantities, these are quantities that depend on other quantities. Derived quantities are quantities that depend on other quantities. An example of derived quantity, let's say we have acceleration. Acceleration is a derived quantity. That is, we are going to get the quantity based on two components of the fundamental quantity. And here we'll be having acceleration. For acceleration, we are going to be having Fn, which implies force, acceleration, which is going to be equals to the displacement, which is velocity over time taken. So this also, from velocity, we still have another derived quantity, and that is distance. Velocity is also distance over time. And if you notice, distance is talking about length here. So acceleration is a derived quantity because it consists of other fundamental quantities like the length and the time. We said acceleration is velocity over time, and velocity also is expressed as distance over time, and the distance here represents length. So we have length, which is a fundamental quantity, and we have time, which is another fundamental quantity. So those two quantities comes together and they form what we call velocity. and also they form acceleration. So quantities that are formed from other fundamental quantities that we mentioned earlier, quantities that are formed from them are called the derived, from the word derive. We have to derive them. We have to derive those quantities from the fundamental quantity. And that is why the definition states that they are quantities that depend on fundamental quantities, quantities that depend on other quantities, in quote, fundamental quantity. So let's look at what the definition of fundamental or definition of derived unit will be. We have discussed derived quantity. We also have derived units, derived units, derived units. That will be, these are units, these are units, these are units that depend on other units, that depend on other units. Derived units are units that depend on other units. So derived units also are units that depend on other units, and mostly they depend on the fundamental units. They depend on the fundamental units. They depend on the fundamental units. So I believe you understand that we have derived quantities and derived units. We have derived quantity and derived units. So we are going to consider some examples of derived quantities, and thereafter we are going to take some example on how to derive those quantities. We want to take examples of the derived quantity we have. So if you are following me, we want to list out some derived quantities we have in. So we have derived quantities. We've mentioned one, which is acceleration. We are going to have like 4 or 5 of them mentioned here. Derived quantities, we have volume. Example of derived quantity, volumes. We've talked about acceleration is a derived quantity. We have velocity, also a derived quantity. We have area, also a derived quantity. We have pressure, also a derived quantity. So we have many more derived quantities. We have many more. We can't say we have a particular number of derived quantity. Scientists have always been coming across and getting more derived quantities as technology and science improves. We have more numbers of derived quantity that are still coming up. But as for the fundamental, they are just 7 in number. But for derived quantity, we have many derived quantities in physics. We have many derived quantities in physics. So we are going to consider how we can go about the derivations of this derived quantity. We are going to pick some of them and check on how we can derive the quantities and also their units by some simple arithmetic in mathematics. But before that, I want to make mention of this SI units. I believe some of us would have been seeing this or probably would have heard of this SI units. This is an acronym. S means System International Unit. System International Units. That is, they are units that are accepted worldwide. System International Unit. International Unit. So what do we mean by System International Unit? These are units that are accepted worldwide by scientists. They have been approved by scientists that they are accepted and they are uniform worldwide. That is, example, like length is meter. We take length as meter. Is meter in Nigeria, is meter in Canada, in USA, in South Africa, in South Korea, it still remains what as meter. And that is why we call them system international units. That is, they are accepted internationally to have those units. So mostly when we solve in mathematics or when we solve in physics and we write a unit of such M, we are making use of what we call a system international unit because N here is an SI unit. But for the derived quantity, take note, for the derived quantities, they are different per countries. The way some countries do the derivations of their velocity or probably acceleration might be different from that of some other country. But for the fundamental quantities, they have been approved by the scientists that they are accepted worldwide, and that is why they do not change. They remain the same. All of them remain the same as for fundamental units. So I can say that fundamental units are also known as system international units because all the fundamental units are under the system international units. Why? Because they are accepted worldwide and generally. I believe we get that. If you are with me, please kindly signify with a thumbs up or say yes, I'm with you. If you are with me, please kindly signify. If you are with me, say yes, I'm with you. I want your response in the chat box. If you are with me, say yes, I'm with you, or just drop an emoji so I will know that you are following. Okay. Okay, so let's proceed. We are going to look at some derivations. We're going to look at some derivative of some units in physics, and we'll be considering some questions that are under the UTME question. So I believe I can rub off the board now, since we're on the same page. All right. So let's look at some derivative. We have the first question, application 1. Want to consider some derivative. The question states that the derived units of pressure is dash. The derived unit of pressure is dash. So we want to respond to this question. We asked that what is the derived unit of what? Pressure. And we know that pressure is not part of the fundamental quantity. That means it's a derived quantity. And we need to break it down to know what it is, what the unit is. So we start by stating what pressure is. Let me use P to represent pressure. Pressure is force over time over area. Pressure is force over area. And take note that my force is mass times acceleration, and my area is equals to length times length. Take note that force is mass times acceleration, and area is length times length. So we proceed. We still have to break down acceleration. Acceleration is equals to velocity over time. Velocity over time for acceleration, and velocity also has its own formula. we need to break down what velocity is, and that is displacement over time. Displacement over time. So if we are going to substitute all this in the expression we have here, we'll say that P, which is pressure, equals to, we have said force is this, mass times acceleration. M represents mass, and A, acceleration. So we have pressure equals to, the numerator, which is force, is expressed as mass times acceleration. So I'll write mass multiplied by acceleration, also has its own formula, which is velocity over time. Velocity over time. Then we have everything is over the area which is length times length. So the next line, we need to change also what velocity is. We say it is displacement over time. So we have this to be equals to mass multiplied by velocity. Now we have displacement over time. So let me simplify that to make it more easier. If I have displacement over time, this represents velocity. And we also have under velocity, we have time again. So it's like I'm saying displacement over time, then over time again. So we have this is velocity over time. So we have to substitute this value for velocity here. So we have velocity here is displacement over time. Then we have, that is just velocity that we substituted. Then let's return back the time under it, time. Now I can use brackets and close this, divided by, the denominator is length times length. Length, let me use acronyms. Let me use L times L, representing length. So we have pressure now to be equals to mass. What will happen here is that there will be a reciprocation. If I have, let me say A over B over C, this is what we'll have. So we can use this to judge what we have here. So we're going to have a reciprocation in this aspect. So not to get it twisted, let's take it one after the other. Mass multiplied by, don't forget we have time here. So if you are dividing it by time, that means we can bring up the value of time upward. So we'll be having displacement over time times time. That's the simplification we'll be having. That is, time will multiply time now. Because this is, like we are saying, divided by, so this will change to 1 over time. So that's why we have multiply by time here. So brackets divided by length times length at the corner here. So we'll continue to have mass times displacement then this is equals to time over time multiplied by time. So we have divided by length times length. So if I change division, I will have multiplied by 1 over length times length. I believe we'll get that. We have length over, we have 1 over length times length because I've changed this division sign. I've changed this division sign that I have here to multiplication. So I'll be having 1 over length multiplied by length. So we have pressure to be equals to mass. Take note that mass we have mass times the displacement also is measured in length. So displacement is measured in length. So that is when you move from a point to another point, what you are measuring is the length you've covered, the length you've covered so far. So let's replace displacement by length. Then we have time multiplied by time times 1 over length times length. 1 over length times length. So we can now say, okay, this length can cancel one of the lengths here. So we'll be left with 1 at the denominator. P will now be equals to mass over what we have is time times time multiplied by time, then times the length left at the other side of the fraction. So we have to replace all this now by their units. Mass is measured in kilogram, time is measured in seconds, and length is measured in meter. So it means P equals to kilogram, that is for mass, over S, which is seconds times meter. And expressing this, we are going to have kilogram, we have per meter. Don't forget that the meter is a denominator, so we have per meter, that's raised to power 1. Then we also have seconds. Seconds times seconds is seconds squared. So we have seconds per seconds what? Squared. Now, why do we have -2 -1? Is because the seconds here, second square is a denominator. So when we divide it, it's expressed as -2. And when we divide it also by m, it's also expressed as what? -1. So this also can be written as kilogram per meter per second square. So is either we write it in this way or this way. Kilogram per meter and also per second square. Some people might prefer writing it in this way. Kilogram per meter second square. So we have the derived quantity of pressure to be kilogram per meter per second square, kilogram per meter per second square. So the derived quantity of pressure is kilogram per meter per second square. So most of the time, we can be asked to give a derivative of a particular derived quantity, especially in exams like JAMB. You'll be asked questions related to this to get the derivative. So I believe we understood how to derive a quantity. And the most important part of it is that you have to know the fundamental units, because you'll be needing a fundamental unit to get to your derived unit. You have to know the fundamental units, which are the one we listed earlier. So if you understood what I've done so far, please thumbs up in the chat box so that we can proceed to the question and answer session. I have some UTME questions for us to answer. They are just CBT questions. Just pick the option. Okay, thank you. I've seen someone to reply. Okay, so we can proceed to the question and answer session. I have 2 questions to ask us to solve. 2 questions for us. Okay, the first question, and I want your response in the chat button, in the chat box. The first question is, which of the following is a fundamental unit? So I'm going to rub off the board so I can write the options. Which of the following which of the following is a fundamental quantity? So this is UTME question. UTME question 1998. So we are given options. Options for that. We have Newton, Joule, watts. Then the last option is seconds. So the question is, which of the following is a fundamental quantity? So I need your response in the chat box. Which of the following is a fundamental quantity? Yes. Your response, which of the following? Here we have Newton, joules, watts, seconds. Which of the following is a fundamental unit? Sorry, it is units. Which of the following is a fundamental unit? Which of the following is a fundamental unit? I'm expecting our response in the chat box. Yes, which of the following is a fundamental unit? Seconds. Accurate. Thank you. That is correct. Seconds is the correct answer. That's awesome. Okay, another question quickly. Another simple question for us, which I know we're going to get it. Now you're going to tell me which of the following is not expressed correctly. We are having the unit and the quantity now. The unit and the quantity. So we have force. In brackets, we have the units. We have time. We have another one. Okay, we have currents. Then we have the last one. Okay, we have the next one, pressure. Okay, so the question is, which of the following is wrong? This is option A, B, C, and D. So we have the quantities and the units in brackets. The quantities and the units in brackets. So select the one that is not well presented. That is, which of the following is odd? Okay, pressure, accurate. Why? Because pressure is not measured in Kelvin. K here represents what? Kelvin. It is temperature that will measure in Kelvin. Pressure is not measured in Kelvin, but is measured in what? Pascal. And we've done a derivative of pressure, and we notice that pressure is having the unit. This is the unit of pressure, not Kelvin. Or it is this or Pascal. Okay, this or what? Pascal. So, okay, thank you so much for those great responses. For us to have a wide knowledge about fundamental quantities, I'll refer us back to the app. Do well to visit the A1 Tutor app. There you are going to have fundamental quantities under SS1 as a class. You have the video lessons there. You have the lesson notes, and also you have access to CBT questions that are related to fundamental quantity. Do well to check the A1 Tutor app for a detailed video on fundamental quantity. Also, you can do well to check our YouTube channel, A1 Tutor. Follow, subscribe to the channel so you can get notifications of our latest video that will be uploaded. And peradventure, there are some topics you still want to go through, you can have them in full on the YouTube channel. So do well to subscribe, do well to like, and do well to share the YouTube link to your friends also so they can learn. Tomorrow will be another day, and we'll be meeting also the same time, the same hour. Please ensure you make yourself available. Don't forget, it is always good to practice. Practice make perfection. So practice questions on the CBT session of the app. So that will help you to master, most of the questions that are related to UTME exam. Thank you so much. If you are with me, please thumbs up. We have come to the end of the class for today, but I want to be sure that you have been with me from the beginning of the class to this moment. So I want your emoji. If you are with me throughout the class, thumbs up and say, yeah, I was there. Okay, thank you, Abiodun. Can I have one more emoji? Okay, great. Okay, great. So please do not forget, tomorrow we'll meet again, tomorrow for another subject. Ensure you are available for the class. Do not miss any of this live session because they are very, very much impactful. Thank you for your time and see you tomorrow.